Good afternoon, this is Schweitzer. We're going to run through a question that will add one small wrinkle into this problem, and that is how much energy is lost, or you may even change. So let's just kind of recap the problem. We have an individual who is going to be running in this direction, apparently having a football. This person weighs 90 kilograms and is running at 10 meters per second. We have another guy running in this direction, and it is going to weigh 120 kilograms and is moving at 4 meters per second. These two people will collide, forming some sort of tackle component. What speed and at what direction will this mass be moving? Will it move this way or will it move this way? And then what is the speed at which this will occur? And then comes in the little wrinkle that we'll add is energy lost. Now in this question asks what is the energy lost, but in other questions they may have to ask you is energy being lost? Okay, so that's an alternate version of this question. So for the first question, we need to calculate momentum and determine the conservation of momentum. In this case, we have the momentum, so number one here, momentum initial equals momentum final. This is going to be the mass. Let's call this player A, and let's call player B. The mass of player A, the velocity of player A, plus the mass of player B, velocity of player B, equals the mass. Now, because they formed one piece, they'll have the mass will combine, and the velocity together will be their own true velocity at the end. I am solving for this piece right here. So mass of A is 90, velocity of A is going to be 10. I have plus the mass of B, which is going to be 120, and then the velocity for this guy will end up being negative because I'm going to say it's going the other direction. So I'll deem that as being negative, negative 4. The total mass would be 210, and we're looking for this velocity. So do our math. 900, 120 and times 4 is 480, and it would be a negative 480 equals 210 V. This 480 minus 900, or solving for that, will be a positive 420 equals 210 V, and V will be positive, so I'm traveling to the right at 2 meters per second, and that is the answer to number 1 on this problem. Number 2 is stay okay. Was there energy lost? So I'm going to go energy initial, energy final. Because these things aren't running up a hill or doing any other type of energy, we're going to say basically it's all the energy is in the form of kinetic energy. For I have player A and player B, and afterwards I have this A-B conglomerate. And we're going to use 1/2 mass velocity squared for this. So in this case, and you could just subtract them, do a final minus initial if you'd like. Energy final minus energy initial equals the change in energy, and that would be fine. Or you could just create the energy before, energy after, just look at the difference. So energy A is going to be 90, again mass 1/2 mass velocity squared. The velocity is going to be 10 squared, plus B is 1/2 120 and 4 squared. My energy does not have a direction, so I'm not going to put negative on that. It's just energy. And then this side here is 210, 1/2, times, and I have now this velocity at 2 squared. Alright, so these are my two energies, energy before, energy after. So let's do our math. 10 squared is just 100, times 90 times 0.5 equals 4,500 joules of energy. And then this guy is going to be 0.5 times 120 times 4 squared, and we get 960 joules. So beforehand we have 5,460 joules of energy before we start. Afterwards, I have only 420 joules of energy. So if you subtract these two, we get 5,040 joules of energy is lost. Now, in this case, we have a couple of unique situations. Usually, in this case, we have a couple options as far as energy being lost. One particle slamming into another particle. We could have just an absolutely crisp, clean bounce, where they would simply bounce off one way and bounce off the other way, and we would have zero energy loss. Okay, we call this elastic. So that being said, this particular situation was different in the sense that one item combined and hit another item, and they actually collided and formed this sort of new piece, but they could have bounced off. Either way, in this collision, energy is being lost during the collision, and we call this elastic. And in fact, if they stick together, we call it perfectly elastic. Okay. Now, in this case, energy is being lost. It would be very unique to have a situation where energy would be higher in the end. How could you do this? How could you have, well, I mean, technically, if one item collides with another item and you get more energy in the end, well, we'd have to have some outside source of energy. Okay. In this case, because we have loss, that's pretty typical. Okay. So this problem would be framed in a couple of ways. One where is a collision elastic? What I would do is I would check my energies to make sure they're the same. If they're not, then it would be if they're the same, it'd be elastic, and if they're not, it'd be inelastic. Looks like I wrote elastic, so inelastic. Okay. Elastic means bounce, no loss of energy. Inelastic is one word, it's just the opposite. Sometimes you can get situations where, let's say, you have, a typical example might be an airplane, okay, and an airplane's flying through the air, okay, and it would essentially explode. Several pieces, but for simplicity, we'll say one piece goes one way, one piece goes the other way. So it's breaking up and it falls down. In that case, even anything that would be simply breaking apart should have a loss of energy. And crime scene investigators would look and say, okay, based on where the pieces are landing and how they're going, we can use the conservation of energy and momentum. So, okay, well, were the pieces just simply break apart, or Was there extra energy on the inside here that caused one to go one way, one to go the other way? So in this case, loss of energy, or did it gain energy from an outside source? This could be some sort of explosion. Okay. So it's getting excess energy from something like maybe an explosive. And loss of energy would be due to, in a sense, as the one part exited from going one way, one part exited this way, there obviously is loss of energy just from the ripping and tearing of the piece apart. So there's a lot of applications for conservation of energy and conservation of momentum. From this, we have a review problem solving for a V2. That's a review. Adding here is this idea of kinetic energy, and is an elastic or inelastic collision. Thank you.